See, here some problems are provided here. Calculate the mass of the following. We should calculate the mass. First they provided 0.5 moles of N2. N2 is nothing but molecular weight. So they provided the molecules and we should require the relation between the mass. What we know originally, 28 grams of N2. Why? Because each molecular weight is 28 grams. 28 grams of weight, that is nothing but 1 mole. Sir, why you taken this relation only? They are asking the relation between the moles and as well as mass. In the previous topic, what we given? 28 grams of N2 is nothing but 1 mole, which contains 6.022 into 10 power 23 number of molecules of N2. So here I consider only relation. So here 1 mole contains 28 grams. This 1 mole of N2 becomes 0.5 moles. Now 1 mole of 28 grams, 0.5 moles considered as x grams. Now x is equals to, what happens? 1 mole becomes 0.5. 28 grams also will be reduced. Now x is equals to 0.5 by 1 into 28. 0.5 can be written as a half into 28. Then x is equal to 14 grams. This means 1 mole of nitrogen molecule, N2 means nitrogen molecule, weighs 28 grams, then 0.5 moles of N2 molecule becomes 14 grams. Let us go to the example 2. See in this example 2 what they given? N atoms, nitrogen atom, single atom we should consider. How many moles that to be? 0.11 mole. Now we know that 1 mole of N atom. What is its atomic weight? 14 grams. 1 mole of N atom weighs 14 grams. But here how many moles they are asking? 0.5 moles of N atom. 0.5 moles of N atom weighs how many grams? You consider this as x. Now what happens? I equate the value of x. 1 mole 14 grams, then 0.5 moles less will be there. So it can be considered as 0.5 by 1 into 14. Now x is equal to half into 14, then x is equal to 7 grams. This means 1 mole of N2 molecules weighs 28, 0.5 moles indicates x. Now x is equal to 0.5 by 1 into 28. Why? Because as the number of moles are reduced, their molecular weight also will reduce. Here they provided the molecule, here they provided the atom. So we are considering the atomic weights. Now let us discuss the third problem. Here now they provided the number and then they are asking the mass. What we know? They provided the number. We know 6.022 into 10 power 23. Here number of N atoms. So 6.0223 into number of N atoms, nitrogen atoms. We already know its weight is 14 grams. Sir, why you taken grams? Why? Because they are asking mass. 6.022 into the number of N atoms weighs 14 grams. Then the number is reduced. That is 3.011 into 10 power 23 number of N atoms. What is this atomic weight? That is x. See here, number is reduced to half. Then automatically, simply we can say the weight is also reduced to half. Easy method. But x is equals to, number is reduced, so 3.011 into 10 power 23 divided by 6.022 into 10 power 23 into 14. Now 10 power 23, 10 power 23. Here this is 1s and as well as 2s. Easily will get cancelled because 3 2s are 6, 0 0, 1 becomes 2. Here also 1 becomes 2. So 2s. 2 1s, 2 7s. So X is equals to 7 grams. This means 6.022 into 10 power 23 number of N atoms is 14 grams. Sir, this is not provided. Now that is there in the concept of mole concept. That is only the mole concept. By applying the mole concept, we are applying here. Now, if you see the fourth model, you can solve this model easily. What are given? 6.023, 6.022 into 10 power 23 N2 molecules. These many molecules, N2 molecules, that is nothing but 28 grams. This is the concept of mole, basic concept of mole. They are asking that only. Means 6.022 into 10 power 23 N2 atoms can weigh 28 grams only. This is the answer for the fourth question. Like this, we are going to apply the concept of mole in various concepts. Let us solve one more example what is provided in the textbook. Now in this second model, they provided like this. Calculate the number of particles. Means we should find out how many particles are there in the given mass. We require the relation between mass of the given atom and as well as number of particles. As we already said earlier, first one, 46 grams of Na, sodium is provided. Originally, as per the general representation of sodium, 11 Na23. This means 23 grams of sodium may have the number of particles. They are asking number of particles, that is 6.022 into 10 power 23. Here grams is came, so that is nothing but we can write particles of Na. This means 23 grams of sodium. This is only the concept of mole. In a mole, that is nothing but 23 grams of the sodium. This 23 grams of the sodium we are considering as what? 1 mole. Means 1 mole of sodium, that is nothing but 23 grams of sodium, having a particle 6.023 into 10 power 23 particles. Now they are asking 46 grams of sodium. 46 grams of sodium. No, we should not consider this one as mole. This is only the fundamental. So 46 grams of sodium contains X particles. Now the formula for X is equals to 23 grams becomes 46. That becomes 46 by 23 into these many particles 6.022 into 10 power 23. By taking the equal ratios and as well as algebraical expressions. Now 23 ones, 23 twos. Then X is equals to, if we multiply 2 twos are 4, 2 twos are 4, 2 zeros 0, 0.6 twos are 12 into 10 power 23. We should not multiply 10 power 23 with 2. Why? Because 2 is not a decimal fraction, it is a numerical fraction. We should not multiply the decimals. Then what is left? Particles of sodium. This means 23 grams of sodium, which is called 1 mole, contains 6.023 to 10 power 23. 46 grams of sodium is twice of those particles. This means it becomes 2 times. Now consider the second example. See, in the second example, O2 is given. That is the clue. What is the meaning of O2? It is a molecule, not an atom. So we should consider here molecular weight. Atomic weight of oxygen is 16. Then molecular weight is 32. This means 1 mole of O2. That means it weighs 32 grams. That means it contains 6.022 into 10 power 23. If it is molecules, then this is also becomes molecules of O2. This is the basic concept of 1 mole. Now here how many grams is provided? 8 grams of O2 is provided. They are asking number of particles. Now we should consider relation between this and this only. Now this becomes 8 molecules of O2. I required the value of x. 32 grams becomes 8, means it is reduced. So that is 8 by 32 into 6.022 into 10 power 23. 8 ones, 8 fours. Now 4 ones, 4 ones. Now it becomes 1.414. 20 is left. Next 5. Again 20. 5. 5. Now x is equal to 1.555 into 10 power 23 molecules of O2. This is the method to explain in the case of that. Now let us move on to the third problem. The third problem, 1 mole of hydrogen. Here they should not provided either it is atom or otherwise molecule. Then what should we do? If they won't provide it, generally we are going to consider it as molecule only. Why? Because hydrogen gas will be there in the form of molecule. So for that we are going to consider it as hydrogen molecule. Now let us consider here they given now mole. 1 mole of hydrogen. 1 mole of hydrogen. Atomic weight is 1. So molecular weight is nothing but 2 grams. That contain 6.022 into 10 power 23 molecules of hydrogen. Molecules of hydrogen. Now what they are asking? 0.1 mole. 0.1 mole. 1 mole of hydrogen contains 2 grams, so this much is there. Here they given the relation between mole and particles. Now we should consider this relation. 1 mole and as well as particles. 1 mole of hydrogen contains those many particles. 0.1 mole of hydrogen. No need of the grams. They are asking here. So this value can be considered as x. Sir, what about the grams, sir? That does not ask in the problem. So for that they ask for that only. 1 mole becomes 0.1. Then x is equal to 0.1 by 1 into the number of particles 6.022 into 10 power 23. Now x is equal to 0.622 into 10 power 23 molecules of H2. This is the answer for that. Why? Because 1 mole these many molecules, then 0.1 moles how many molecules? 1 mole is reduced to 0.1, then the total number of molecules is also reduces. Let us discuss one more example model. In this, we want to convert the given weight into moles. Now they have required the relation between the weight and mole. What is the general relation in the first one? That is in the case of oxygen gas, 1 mole of O2 can weigh 32 grams. Having a particle of 6.022 into 10 power 23, you already know that. We are not at all going to consider. Why? Because that does not ask for the particles. Now here they given 32 grams of oxygen is nothing but 1 mole. Here 32 becomes 12 grams. 12 grams of O2. 12 grams of O2, that becomes x moles. Now I require the formula for x. 32 grams becomes 12. Now it becomes 12 by 32 into 1. 12 ones 12. Is there any cancellation is there between the 12 and 32? No, it does not carry forward directly. So we can take like this. 32 point, if you put it becomes 0. 3 fours are 12. Of course directly 12 is there, but it does not carry forward directly. So we should consider the 3. 3 twos are 6, 3 threes are 9. By subtracting it becomes 4, 11 and 9, 2. Point if you put 0. 3 eights are 24. But Here 2 is there more than that. So for that it can be considered 7. That's enough for us. Now X is equal to 0.37 moles. This means 32 grams of oxygen. Sir, it is not provided. That is only the definition of concept of mole. 32 grams of oxygen shows 1 mole. Then it has a number of particles 6.023 into 10 power 23 moles. Now go to the second example. What is the second example? 20 grams of water they given. We know the 1 mole of water. 1 mole of water. What is its weight? 18 grams of H2O. Why? 2 atoms of hydrogen and 1 atom of oxygen. But these 18 grams are not here now. How many grams? 20 grams of H2O. These 18 grams becomes 20. Now here it becomes X. Now X is equal to 18 grams becomes 20. Means 20 by 18 into 1. Why? Because here 1 mole is there. By multiplying 18 ones are 18. Point then it becomes 20. Once again it becomes 18, that is 1. So into 1 is also nothing but 1.1 moles of water. These are all various examples. Come to the question number, third question, that is 22 grams of CO2. They provided here 22 grams of CO2. We already know originally 44 grams of CO2 is nothing but 1 mole of CO2. Why? Because its molecular weight is 44. 12, 16 plus 16, now it becomes 30. Now here how many grams given? 22 grams of CO2 they provided. That is nothing but how many moles are there? That is nothing but X moles are there. Now X is equal to 44 becomes 22. Now 22 by 44 into 1. Ones 2. Now 1 by 2 is nothing but 0.5 mole. This means 22 grams of CO2 is equals to 0.5 moles of CO2. Like this we should solve some of the problems. Of course, one more problem is there, table column is there. Let us discuss that problem also. Now let us discuss this example which is there in our regular textbook, page number 73 of our SCRT textbook. See here a table is given. Name, that is atomic oxygen. Atomic oxygen. So it has a symbol, that is O. Whenever the symbol is O, its molar mass is 18 grams. As per the concept of mole, it has 6.022 into 10 power 23. Here it is atom. Now it also becomes atoms of oxygen. Second one, molecular oxygen. One molecular oxygen is nothing but O2. Each atom having 16 grams, then it becomes 32 grams. 32 grams of oxygen has 6.022 into 10 power 23. Instead of atom, we should write molecules. Molecules of oxygen. Now come to the sodium. Sodium is a metal. It is always will be monoatomic. I already explained. That is Na. Whenever Na general representation is what? 11, Na 23. So the molar mass is 23. Is it having atoms or molecules? It is in atomic state. Then automatically it has some atoms. How many? 6.22 into 10 power 23 atoms of Na. Come to this sodium ion. Either sodium ion or general representation is Na 1 plus. Molar mass is 23. Remember, there is no relation between the number of atoms and charge. It is depending upon only mass. So it contains 6.022 into 10 power 23 atoms of Na. Once again remember, there is no relation between the number of atoms and the charge. Only the relation is there between. Why? Because charge is because of either loss of electrons or gain of electrons. Here the number of protons are not changing, so there is no change in the atomic weight and as well as molecular weight. Come to the sodium chloride. Here the formula is NaCl. One atom of sodium is 23, chlorine 35.5, totally it is 0.5858. So its molecular weight is 58.5. Contain how many units? Value does not change, that is nothing but molar Euler chart and as well as Avogadro diagram. 6.022 into 10 power 23 units does not change. Come to the next one, water. Water formula is what? H2O. Here 2 atoms of hydrogen, that is 2 of 1 plus 2 of 16. 2 of 1 is 2, 32. 16, 1 atom of oxygen, that is 18. Now totally it becomes 18 grams. 18 grams of water contain 6.022 into 10 power 23 units of H2O. Why? Because 18 grams is 6.022 into 10 power 23. From this, we can understand clearly the concept of mole. 16 grams of oxygen atom, 1 mole. 16 grams of oxygen atom, 1 mole, having a number of atoms are 6.022 into 10 power 23. 1 gram of hydrogen, which is called as 1 mole, having 6.022 into 10 power 23 atoms of hydrogen. Same like that only, 32 grams of oxygen molecule if we consider, that is nothing but 1 mole, having 6.022 into 10 power 23 molecules of oxygen. Like this, we can calculate the relation between the concept of mole and as well as number of atoms. Thank you.